Hello everyone, welcome to this demo on Google Kubernetes Engine by Network Kings. So I'm a, I will be the instructor for today. My name is Rohit Mishra, and about me, I'm working as a cloud security deployment engineer, and I got GCP Associate Cloud Engineer, Professional Cloud Security Engineer, and Professional Cloud Architect certifications. And we are discussing here Google Cloud Security Masters Program uh, conducted by Network Kings. And so let's see like what is covered under this security masters programs, which will be helpful for an individual who is enthusiastic in learning cloud technologies or who is willing to develop his career in cloud security. Yeah. So content for this demo. So initially we'll discuss few aspects of Google Cloud Security Masters programs, like approach for this course, what all tracks from the GCP certifications will be covered in Cloud Security Masters program, and what's the motive behind designing this. And then we'll today, for this demo, I have planned one of the compute engine resources, I will say, inside GCP, which is known as Google Kubernetes Engine. So we'll see like how Google Kubernetes engines help us to deploy our containers. But before doing that, first of all, we will cover basics of containers, like what are containers actually. Then we'll see how to create a Docker container, because Docker is widely used containerization technology, I will say. And that's why we'll take example of Docker and we'll create our first container, which will be Apache 2 web server running on Ubuntu. And like this demo is not particularly for Docker or Docker containers. We will be targeting Google Kubernetes Engine in this. But yeah, to have some overview of containers, I have added this sections of basics of container, because here in master's program, what we are doing is to learn the destination technology. We are focusing on the basics needed to learn those technologies as well. Like most of the times, if we are studying cloud, the alone cloud knowledge is not sufficient. Like suppose if you purely study GCP and if you go for an interview, it will be difficult because they will be judging you based on the practical exposures, right? Like somebody who is working on any cloud like AWS, Azure, or GCP, it's not like if he is excellent or he have studied somewhere cloud technology, he will get the job quickly. He will have to understand 2 3 domains at least, right? Because for a cloud engineer, he should be able to deal with containers. He should be able to do some DevOps related things, like he should be able to provision his infrastructure via his or her infrastructure via code. He should learn some automation things, at least 2 3 domains. If you are having knowledge of at least 2 3 domains, then like interviewer will be convinced like, yeah, this guy is totally a production guy and we can take him for whatever the role they are interested in. So that's why here what we are doing is to learn any upcoming technologies, we prepare our candidates to learn the basics of that as well, or the domains which are directly attached to that technology. Like here, as we are discussing Google Kubernetes Engine, so it's always good to discuss basics of container before directly jumping into the GKEs. GKEs will be the short form for Google Kubernetes Engine, which I will be using multiple times in this demo. So in basics of, as I said, creating a Docker container to run Apache 2 web server on Ubuntu, then we will create a custom image from the running container. So what we will do is we'll pull a image from the Docker Hub. So Docker, I will show you like everything, what is Docker Hub, how to pull image from the Docker Hub, how to run a container from that image. So this is an image which we took from the Docker Hub. So now what we'll do is, in that image we'll modify, like what we'll do is we'll add a index.html, like our custom HTML code. We'll add just a simple code so that it will throw some output in web. And then that configuration we want to be created under a custom image, so that next time if I run that container, I don't have to modify the index.html file, and that web page will be readily available. So that's why I will create a custom image from the running container and then upload this newly created image to the Docker Hub. Now everything which we are doing for this particular demo only. So as I'm uploading this to Docker Hub, definitely I will use it somewhere in this demo. Then we'll move to Google Kubernetes Engine, GKE, where we'll see overview of GKE, then deploying a Google Kubernetes Engine cluster with autopilot configurations. So first of all, we'll see, like in the overview, we'll see what types of configurations are available when we are creating a GKE cluster. And then for this demo, I chose autopilot configuration, which is recommended by GCP. And then we will deploy a containerized application to Google Kubernetes Engine. Here we will use the custom image uploaded in Docker Hub in the previous section of basics of container. So that's why I have added these two topics for today's demo, and I will correlate these two topics so that at the end we will have the complete understanding of what are containers and how using GKE, which is a managed hosting from the Google, we can use that container as our workload inside our GKE cluster. So we'll see what is maybe some terminologies like workloads, containers. These are difficult to grasp at first, but yeah, we'll definitely see what are those in details. So let's move throughout this course. So first of all, as I said, overview of our Google Cloud Master programs. So here we will divide this program into 3 GCP courses certification track, and each of these certificates has been discussed and chosen according to the market needs, I will say. So first of all, to start with, like to have a basic understanding of what is there in GCP, what to use. Like suppose you are in an interview and interviewer is asking like, I want to deploy my containers. Okay, so what services I should use? So you should be able to answer it. We should use the compute engine services inside which we can go with GKE, right? Something like that. So here in GCP, Associate Cloud Engineer will cover focuses on basic to intermediate GCP services skills. Then once this is done, we'll start with GCP Professional Cloud Security Engineer, where we'll deep dive into GCP security services, like what are all security services within GCP plane. We will discuss all those. We'll do labs, multiple labs, and most of the labs which we will do will be linked to some of the production needs, like which organization are already deploying. So our labs will have touch of that. And then at third, finally, we'll discuss GCP Professional Cloud Architect inside our Security Masters program, in which we will master GCP services. And again, as this complete program is marked as Security Masters programs, so in all these 3 certification tracks, you will get whatever is needed to clear the certifications from the Google's curriculum perspective. Addition to that, we will cover the security aspects of each of these courses. Like wherever the topics will be related to cloud security, we'll focus more there so that a candidate who has successfully completed the Security Masters program should have no issues appearing for a cloud security engineer job role, I will say. So yeah, as we said, the diagram depicts the same. We'll start with GCP-S, then we'll go to PCSE, and finally PCA, which is a professional cloud architect. So how to start? We made a research and found GCP-S course will be a best start for GCP. It is not that basic, because if you scroll through like the GCP official documentation, they will suggest a digital cloud leader certification for someone who want to start his career or who want to start learning with GCP. But yeah, as we are helping our candidates to gain the cloud knowledge as early as possible. So that's why we have started with ACE, so that they can save some of their time. And we'll cover all the prerequisites which are there in digital cloud leader course, so that students or candidates will not have to worry about that, like if they have missed something in the basics. We'll cover everything from the basics. And not to worry, as we'll design this program in a way you will be comfortable taking the exam without having prior cloud experiences. So you can mark this. And then as we will start it from GCP Associate Cloud Engineer, focuses on basic intermediate GCP services skills. So this will be our start point. Who should enroll? Now, Google recommend this certification to below candidates. Like now we are discussing everything about associate cloud engineer here, as this is a start. So has experience deploying cloud applications and monitoring operations? Like if you have some experiences deploying cloud applications and monitoring operations, or has experience managing cloud enterprise solutions. So cloud enterprise solution means you are working for an enterprise which already has a cloud hosting, any of the cloud hosting, and you have at some point of time you have managed that cloud enterprise solutions. Then this is the best certification for you. This is from Google recommendations. Now, target audience for this course will be the certificate for associate. GCP is ideal for almost all IT personals. Like it's not like there is a barrier. Like because if you will go through the course details or exam guide of the associate cloud engineer, you will see that they cover everything. They will cover compute, they will cover storage, they will cover networking, they will cover security. So it's not like someone who is good in compute should only take this cloud course. No, it's not like that. Cloud is for all, I will say. Because at some point of time in our future or near future, you will see that whatever technology you are working on will get migrated to cloud, because each and every organization is now focusing on cost control, right? And on cloud, the basic purpose of migrating into cloud is to save some cost, right? Then, so target audience will be for our courses will be cloud engineer, software engineer, cloud administrator, on-prem network security, database engineer, as I said, interested in cloud technology. Anyone want to develop his skills in GCP, right? So these are all the target audience for this course. Now today, as I have taken containers as our demo. So before directly jumping into the container, I want to show you like compute services in all three major cloud providers. So we'll discuss that. Like, if you are like confused, like which cloud technology I should start studying on. So it's like if you will see this diagram, which I took from I collected it together from each cloud providers. So for compute hostings, like compute services, basically computation, which like compute engine we can say. So for that compute engine, there are these all three offerings, four offerings are there. Like first of all, virtual machines. If you want to build a virtual machine on cloud, so in GCP they will call it as Google Compute Engine, and in AWS they will call it as EC2 instance, and in Azure they will say it as Azure VM. For platform as a service, in GCP you will get App Engine, in AWS you will get Elastic Beanstalk, and in Azure you will get App Services. Similarly, for serverless offerings, in GCP you will have Cloud Functions, AWS will have Lambda, and Azure will have Azure Functions. Now it comes to containerization. In containerization, in GCP you will have Kubernetes Engine, in AWS you will have Elastic Container, and in Azure you will have Kubernetes services. So you can see no cloud provider is lagging anywhere in terms of compute services offerings, right? Everybody will have similar type of hostings for compute, but they will just name it differently. So it's not like that if you studied AWS, you are missing from the overview of the services. You are like this service, compute service is not available within GCP, but it is available in AWS. No, if it comes to compute, each of the cloud providers will have this functionality. Yeah, but the naming and few other things will be different. Otherwise, most of the things will be similar. And if you are expert in at least one of the cloud provider domain, I will guarantee you like it won't take more than a month for you to understand the other cloud provider technologies. So that's why I took it as a initial start before directly jumping into the containerization, because you should be aware like containerization comes under compute, and in compute we have all these offerings. And for the containerization, we will discuss Kubernetes engine, which is in GCP, because we are dealing with GCP here. But if you go to some AWS or Azure classes, you will see this name, Elastic Container and Kubernetes Service. And good thing about GCP is this Kubernetes engine is a in-house deployment or development of Google. Later it becomes open source and now everybody is using it. So it's that popular, Kubernetes engine. So let's start. First of all, as we discussed, we'll start with basics of container. So first of all, what is containers? Containers are a lightweight packaging technology that bundles an application code, configuration files, libraries, and dependencies into a single unit. This packaging allows applications to be moved and run on any operating system's environment with little to no modifications. Like, the restriction of operating system is not there in containers. Like, if you are running a container, you can run containers everywhere. Just you need a container engine. So that container engine will help you to run your containers. We'll see that in details. So first of all, the main differentiation will be between containers and virtual machines. So we'll see that what are the major difference. Like, virtual machines and containers are both resource virtualization technologies. Like, in virtual machines also, what you are doing is you are virtualizing a compute. Like, suppose you want a server, instead of getting a bare metal hardware, you can virtualize your hardware using hypervisors, right? So if you are having a very big stable hardware, what you can do is you can use the virtual machines technology, and you can divide that hardware into multiple logical VMs, which will be nothing but a separate operating system. But containers are the lightweight things. They are not like full-fledged operating system, but they have all required configuration files, libraries, and dependencies to run a particular application. Suppose I want to run Apache 2. So if I go with VM, virtual machine, I will have to first choose operating system. Like, suppose I want to run Apache 2, I will go with Ubuntu, let's say Ubuntu or Debian. So what I will do is, I just want to host a single static website, for example, HTML. And for that, if I go with VM approach, I will have to build a VM. I will have to secure a hardware, then build a VM, and over that VM, I will install the Linux operating system, which is suppose Ubuntu, and on the top of Ubuntu, I will install Apache 2. But if I want to go with and that definitely that will consume memory, right? Because operating system will have other files also, and the motive is just to host a static web page of HTML. So we can choose containers because containers are lightweight and they will serve the purpose. So there will be images at Docker Hub you can choose, and you can create your Apache 2 containers from them. So we'll see that how to create that. So the differentiation, first point will be how they work. VMs are digital copies of physical machines, as we discussed, that run their own operating systems, right? Virtual machines have their own operating systems. Containers are packaged that contains an application code and dependencies and run on the host operating systems. So containers won't have their own operating system. They will just consist of applications code and dependencies which are needed for that application, and it will run on the host operating system. And there will be a Docker engine which will utilize the resources from your host operating system required for this container to run. Okay. Isolations. In terms of isolation, VM provide a high level of isolations because you are running a separate operating system. So definitely isolation is more in virtual machines from the host operating systems and others VMs, which can be important for security. Yeah, if you want complete security and we are more, then VMs can be beneficial sometimes. But containers provide lightweight isolation from the host and other containers, but not as strong as security boundary as virtual machines. But in here, like, we need to think about like what we are dealing with. Suppose we are running a container which is running on a host operating system, and that operating system or a machine is already in a secure environment, then we don't need to think about that, right? It's like between containers, that amount of security is not there, which is available in terms of VMs. But if we are talking about complete cluster, and cluster is already in a secure environment, then you can utilize the security as well as the efficiency of containers over virtual machines. So as you will go deep into this, you will understand those things. And then resource usage. VMs are typically more resource intensive than containers. Definitely, if you are building a Ubuntu machine, at least you will need 2 GB of space. But a same container with Ubuntu, Apache 2, yeah, the target is running Apache 2 here. So in that case, Ubuntu has taken 2 GB of space, but your container will not take more than 200 MB. So you can feel the difference, like. And portability. Containers are more portable than VMs, allowing the same code to run on any device. That's the main advantage, I will say, for containers, because most of the times the issue was this code is working fine on a developer laptops, but when it go to some other environment, there it fails because other environment will have different types of packages, iOS version, dependencies, and that's create a problem lots of the time on deploying the application. So that's why containers are multiple, like bundle everything. That's why the motive of this course is to create a custom image also. And that image you can use anywhere and it will work in a similar way it worked in your environment, because you are bundling the complete image, right? Whatever things, whatever dependencies, libraries are needed for that application, you are bundling all them together into a custom image, and that image can run anywhere. Just that destination platforms will support containerization. Best use cases: VMs are best for hosting traditional workload, isolating risky deployment development cycles, and provisioning infrastructure. So all traditional workload, risky development cycles, and provisioning infrastructure, you can use VMs. Containers are best for building cloud native apps, packaging microservices, and incorporating application into DevOps or CI/CD practices. So if you are talking about like more these days, most of the things will be done using CI/CD practices. DevOps is widely used in software development cycle these days. So containers are used in those cases. So containers. Let's build a Apache 2 web server using Docker, same as we did on VM. Okay, so like we are already running this courses, so that's why it's VMs most of the times we use. But today we will discuss on how to create a Apache 2 web server using Docker. So let's start that. Okay, so now we will start our lab. So we'll build Apache 2 web server using Docker. So first of all, to check if Docker is installed in G-Cloud shell, we are discussing this within our GCP. So that's why I will directly go to my G-Cloud shell. So this is my G-Cloud shell for this project demo GCP new. And if you see, the project ID is amiable mix. And here I have set that project amiable mix. You can use this command to set G-Cloud config set project and your project ID to set the project. And now let's check whether Docker is installed or not, first of all. So you will see Docker version 27.1.2 build this is already installed. And now to pull required image from Docker Hub. So first of all, I will show you what is Docker Hub. Explore. Okay, so let's search Docker Hub with Ubuntu and just hit enter to see. Yeah, so these are all the containers image available at Docker Hub. So Docker Hub basically consists is a repository where all available images are there to use. You can create your own account as I have created, and you can add your own public and private image at Docker Hub also, in short. So as we are discussing here our GCP thing, so I won't go deep into this. So I'm interested in this Apache 2 hosting. So let's click here. And yeah, so this is the image Ubuntu Apache 2 and it says Docker pull command. If you want to pull this image into your local environment, you can use this command Docker pull. So I'm doing similar that amount of task like Docker pull Ubuntu Apache 2. As Docker is already installed into my console, I'm just doing a pull. Okay, so it's done. Now to verify whether this image is now available in our local environment, put a Docker images and you will see Ubuntu Apache 2 latest 221 MB of size. Okay, and now to run container, you will have to use this command docker run -t means in the detached mode. Like if you want to run it in a detached mode, you won't be able to use your shell. And then if you do a control C, your container will get stopped. So that's why I always run it in detached mode if you want to use your existing shell. Then name. So name of this container. So any name you can give. I am giving Apache 2 container. And then port. So what port of the container you want to map with your local. So to avoid confusion, what I will do is I will map same port. Whatever the port our container is using, I will map the same port. So let's run it. What container is this hash means it has generated the hash ID and your container is running. To verify it, use Docker PS. Okay, spelling mistake. So Docker PS, you can see this is the container ID and it is running up 12 seconds. Okay, port I have kept same. All looks good. Now to access the bash shell of the created container, now I want to go into this container. I want to access this container to make some index.html changes. So this is the command docker exec -it, then container ID and bash. So let's copy it. And then here we need container ID. So you can see here is the container ID. Either you can take the container ID or name also, both will work. Always go with container ID. And then what shell you want? I need bash shell. Yeah, you can see root at the rate A855. So which is our container ID. A855. So we are good. Now we need to modify this index.html with this networking's hello from container web server to test it, right? So I will go to cd. Okay, sorry. What I will do is I will first remove this index.html file, and now I will add my custom index.html with this value. I will do a control D. Yeah. To verify this, what I can do is I can do a cat to this destination. So if my required line is added, I don't see it is added. Let me add it again. Yeah, I think it is added now. Yeah, you can see networking's hello from container web server. So this line I should be able to see when I do a curl to this container. Okay. So I'm back to my cloud shell. I exited that container bash shell. Now let's just verify. Yeah, my container is still running from last 2 minutes. You can see created 2 minutes ago and status is up. So now let's do one thing. Do a curl to the local host, because we have mapped port 80 of the container with the port 80 of the local host. 00 is our local host. So now what I will do is I will just do a curl localhost. You can see I am able to get that networking's hello from container web server. So what I did is I pulled an image, Apache 2 image from the Docker Hub, and I have modified index.html. So every time we run this container, this should show this web page, right? This container should throw this web page. Now what I will do is my motive is not to teach you the container here, right? So we are just learning this thing so that we can use them in our GKE lab. So now we can make local image of this Apache web server with custom index.html. So we already have custom index.html. Let's create an image from this running container. Now to create image, we need to use this command docker commit running container name, okay, or ID, anything you can use, and then new image name. Let's name it demo Apache. Okay. Before doing that, first log in to the Docker Hub and check for the image name format to be uploaded. Okay. So I'm into my Docker Hub. Let's go to the repositories section. And here, this is the repository I created for myself. You can create one for you as well. So I will go to the existing one. And Docker command to push a new tag to this repository, use this format. It's saying you can just modify the tag name. Okay. So as I'm creating this image, I will have to follow this tag, sorry, the syntax, and then I can give the name as demo demo image. Let's give this name demo image. So I have created. Now if I do a Docker images now, you will see one which I have pulled for our lab and the one which I created just now, right? With the tag demo image. So now to push this image to the Docker, first of all, we have to log in this CLI with Docker credential. Otherwise, it won't be able to push your image to the Docker hub. So let's log in it. Okay, it's taking my login, but okay, so it's taking the default login which may I have done last time, but this time I want to use this Rohit Mishra 594. I want to use this credentials, but I have logged in into this Docker using my Gmail ID. So let's use my Gmail ID here. So to copy my Gmail ID, I will have this Gmail ID rohitmishra.new40. So let's do that. Now to change it, do a question mark and hit enter. .new40 @gmail.com. Spelling is wrong. Let me correct it. So you need to give your email ID, the same email ID or username which you are using in your Docker hub, and the password for your Docker hub. Okay, let me check it. Okay, so basically I was already logged into my Docker hub. You can see authenticate. Once you log in for the first time to the Docker hub with your credentials, your password will be stored and encrypted in this location. So your shell already saved those credentials. That's why it is directly saying me login succeeded. But if you do it for first time, Docker login, you will get the username and password prompt. Please put your username and password, and then you are good to push your image. So I got this two images, right? One which I already pulled from the Docker hub, but this is the custom image which I created. So I need to push this image now to the Docker hub. To push a new tag into the repository, I already have one image, DJ image, but let's use this format to push a new image. Tag name for us is demo image. Okay. Okay. So it says demo image digest is done. Let's verify. So this DJ image is there. Yeah, you can see demo image is now available 2 minutes ago. So now this image is in Docker Hub. So the purpose of this basic lab is done now. So what we have done is, as planned, we have seen how to use Docker to create a container, and in that container we modified some settings, like we have modified the index.html file, and then we have created an image from that modified version of the container, so that each time we run this container we will get this web page only. So now let's move to GKE overview. So what is GKE? GKE is a Google managed implementation of the Kubernetes open source container orchestration platform. So in the last step, what we have seen is, we have seen how to create containers, right? But creating the container is not sufficient when it's come to production or when it's come to deploying in enterprise world. Because as containers are lightweight, you will create multiple containers. Like for each application will have replicas, like five replicas of each application will be available as a container, so that if one goes down also, other force will take over, or if there is a heavy load, you can create a load balancer so that each containers can systematically distribute the load. So in the production, it is difficult to manage these containers because it will be in huge numbers. So that's why we need some orchestration platform, so that from a single point of place or plane, we can manage all containers. GK is the orchestration platform you can consider, which is used to deploy as well as manage containers. Kubernetes was developed by Google, as I said, drawing on years of experience operating production workload at scale on Borg. So Borg is the initial technology which Google used for this scaling the production workloads. So basically, the birth of this containerization came with the concept of auto scaling. So like according to your need, your infrastructure will scale up and down as required. Like suppose there is a huge load, your infrastructure will go scale up. So suppose you have run 4 containers or 4 virtual machines, but suddenly speed heat count increased, like users activity increased on your platform. Automatically your infrastructure count will also increase, like your VMs count will increase, or if you are running containers, your container counts will increase. And similarly, if the hit counts decreases, like user load is decreased, then the infrastructure will scale down also. VMs numbers will go down, containers numbers will, all these things will be done automatically. Cloud providers already built this technology implicitly within their infrastructure. So years of experience Google has got here in scaling the infrastructure using Borg, our in-house cluster management system. So everything, every offering you are getting on GCP is on their cluster, right? So what is cloud? Cloud is somewhere, someone else data center. So if it is GCP, Azure or AWS, we are using their data centers to host our services. So they are already aware of this, like anytime user load can increase, and imagine like how they are serving all these customers. Like that's why they are having a quite a good of experience in scaling their infrastructure according to the customer needs. And Borg is the technology which has been used by Google, and working through and doing research and development on these technologies, they came up with this Kubernetes concept, which was very famous then, and then it became open source. So that's the reason Azure and AWS is also using this Kubernetes technologies to orchestrate their containerization environment. When to use GKE? GKE is ideal if you need a platform that lets you configure the infrastructure that's run your containerized apps. So if you need a platform which can help you configure the infrastructure running on your containerized applications, such as networking, scaling, hardware, and security. Everything you can manage using GKE for your containerized applications. GKE provides the operational power of Kubernetes while managing many of the underlying components, such as the control plane and nodes for you. So apart from the power of Kubernetes, you will get more features like control plane and nodes for you. It can help you manage all those things. Use cases of GKE. GKE and Kubernetes are used in variety of industries, including robotics, healthcare, retail, education, gaming, and financial service. Everywhere you will see these days they are using GKEs. Few of the examples are AI and ML operations, data processing at scale, scalable online games platform, reliable application under heavy load. I am not going deep into all these things because this demo will be a very big then. So I need to cover this. So I'm moving fast. Sorry for that. So for deploying, how GKE works actually. So a GKE environment consists of nodes, which are compute engine virtual machines. So as I initially told you, we are discussing containers. Containers are part of compute engine resource only. So initially, basically what it happens is GKE cluster. So everybody will anywhere you will see that this application is on GKE cluster, they will say. So because basically cluster is nothing but combination of nodes. And what are these nodes? These nodes are nothing but virtual machines. So that are grouped together to form a cluster. Virtual machines are grouped together to form a cluster. You package your apps, also called workload. So your application is called as workloads into containers. You deploy set of container as pod to your nodes. So basically, if I open a draw, Okay, so let's take this as a one node. This as a second node, and okay. So now this become, this is your cluster as a whole. You can say it GKE cluster, and this is your node 1. To have some fault tolerant infrastructure, definitely you will create more than one node, right? Because if one node is nothing but virtual machine, as we have seen. So if one node goes down, at least you should have some redundancy. So that's why I'm taking node, two nodes are part of this GKE cluster. Now when it comes to your application, suppose this is your application. So multiple application will sit inside these nodes, right? So suppose I have two applications, and a replica of this application I have built here also, and for this I built here. Let me change the color for it as a red. Yeah. Okay. So this is your complete GK cluster. Cluster is nothing but cluster sits on node. So these two nodes are part of this GK cluster. So basically the nodes on which GK is running is called as cluster. And inside node, you will have your workload, which is your containers. So the container image which we have created for our Apache 2 can be considered as workload. And in GK terms, it is called as pod. So inside node, there can be multiple pods, right? This is pod A1. Okay, this for pod for application A, and this is the first instance, and this is pod for application A only, but this is the second instance, right? Because to have some redundancy, we have used these two, because nowhere in production you will see only one node, right? Because production data should be always fault tolerant. So now this will be your pod for application B1, and similarly this will be your pod for application B second instance 2. So this is a simple explanation of what are GK cluster, nodes, and pods. You can, what I will suggest is you can pause this screen and you can go through all this, but I will just highlight on what are the more like critical or important points here to understand. So how GK works, we have seen like GK will have those cluster nodes and pods. And now modes of operation. So modes of operation, GK has the autopilot and standard mode of operation, which offer you different level of flexibility, responsibility, and controls. And best practice is use the fully managed autopilot mode. So let's see why GKE autopilot mode. So this is our interest because we will be dealing with GKE autopilot mode for today. So cost efficiency, you only pay for the compute resource that your workload use while running. Suppose your workload is not in running state, you don't have to pay for it. That's the advantage of autopilot mode. Automation, Google manages nodes, create new nodes for your apps. So the nodes which we have seen in this diagram, these nodes, you don't need to manage those nodes. In the autopilot mode, Google will manage this node. Suppose something happens to this node, Google will take the responsibility and it will create a secondary node for you having the similar configuration. So you don't need to manage that in autopilot mode. Automatic upgrade and repairs. If any repairs or upgrades are needed, Google will do it on behalf for you. Improved security postures and reliability. Autopilot clusters enable many GKE security settings and Kubernetes best practices by default. So as this is a autopilot mode managed by GCP, so security postures and reliability will be managed by GKE. Google in simple terms. You only pay for the compute resources that your workload use while running. So this is something which we need to know, like while the decision making between autopilot and GK standard. And as contrast to autopilot, in GK standard mode, all responsibility lies with you. Like node post, you create and manage group of nodes. Security, GK standard clusters have default hardening measures. So default settings will be there for security, but many GK security features are not enabled by default. You will have to enable it. Scheduling, scaling, resource management, everything is your responsibility if you are using standard mode. Version management, best practices such as automatic GK version upgrade and release channel improvement are off by default, right? So the automate GKE version upgrade won't happen because it's a standard cluster managed by you. You will have to make sure your versions are upgraded to the latest stable release. And you pay for the compute resources on each node, regardless of whether pods run on the node. If pod is also not running, nothing is running. Suppose in this diagram, I don't have these two pods or application container. Still, I will have to pay for this node because I'm managing this node, right? So that's why from cost point of view, it is costly, GKE standard mode. Now, finally, let's get into the action of creating an autopilot cluster. So before that, let's understand few more theory because it's a GKE. It's not like I will say it's a 1 hour or 2 hour job. At least we'll have to sit for 5 to 6 hours and then we can understand, or 3 lectures we need here, 2 hours each. So to understand the GKE in details, because it's a very vast technology, I will say, and most of the organization are using it. So, but definitely from this demo, I will give you an idea, basic idea like what is GKE, how it works, how to configure one using autopilot mode, and what are the things we need to know before saying going deep into the GKE. So pods we discussed are the smallest deployable unit of computing that you can create and manage in Kubernetes. Every pod has its own IP address. As we have seen, pods are the smallest deployment units for your application. Simply container. Deployment. You describe the desired state in a deployment and the deployment controller change the actual state to the desired state at a control rate. Deployment is, suppose I create this, as I said you, like I created this pod for application A, and I want this to be available in 2 different nodes. So this is my deployment. It should not be less than 2. Suppose this complete node fails, it will create a new node and it will make sure that 2 pod for application A are always available. So this is the deployment. So that's why it says desired state. So whatever desired state according to you will be maintained. If you want 4 pod for your application, always 4 pod will be live. Then services, there are different services I have listed here. You can go through them, but I will use today load balancer. So what load balancer will do is exposes the services externally using a cloud provider's load balancer. So this will use Google Cloud Provider load balancers. Again, for load balancer, we have a different sections as we are covering it in demo. So this load balancer service, what it will do is it will map your GKE pod internal IP to an external load balancer so that users from the outside world will be able to access your containers. So in this case, we have built a image, if you remember, to Docker up few times back. Now I will use that image to create a workload or pod here in our GKE, and I will implement this load balancer service so that I'm on internet, right? This PC is on internet. From this PC, I will try to access that container and we'll see whether that web page show or not. Then few things, cluster architecture from side we need to know before directly jumping into the autopilot cluster. kubectl. So kubectl is the main CLI, kubectl, somebody says different pronunciations. So kube control also we can say is the main CLI tool for running commands and managing Kubernetes cluster. So everything we will manage using CLI for this Kubernetes cluster is using kubectl command only. Then cluster, we know all Kubernetes objects that represent your containerized application run on top of the cluster. Node are the worker machines. We know which are the virtual machines. We can go through the deep by pausing the screens. Now, finally, install kubectl and configure cluster access. So first of all, check whether kubectl is installed. By default, it will be installed in your gcloud shell. So this is the command kube. Okay, it's taking some time. Okay, so it took some time, but it says client version 1 28.12. So for me, it is installed. For most of the like free trial, you will see that kubectl is already installed, so you don't need to worry about it. If still you see it's not installed, you can use this command gcloud component install kubectl. Now let's start deploying a Kubernetes engine cluster with autopilot configuration. In this section, we will create an autopilot cluster in our GCP console with minimum required configuration for our lab. As we are touching Kubernetes with a very basic approach, so that's why I'm not getting more deep into it to not confuse you all. But yeah, considering all these points, you will be able to have an overview of what GKE clusters are and how to deploy a cluster and how to run a workload, a sample workload. So let's start. We'll have to go to the Kubernetes engine page in the Google Cloud Console. So let's go to this is my Google Cloud Console. And if you click this hamburger menu, you will see a Google Kubernetes engine page. Just click on that. And this is the overview page. And click create. Create cluster. Okay. Create a new cluster or deploy a container. You can see create an autopilot cluster. It's already taking autopilot cluster as a default. And here is the option is to switch to standard cluster. But for this demo, we are good. Just name it some demo cluster, demo GKE cluster. That suits best. Now your cluster should be one of the GCP regions. So you can pick any of the region. I'm just keeping this as a default US Central one. Now next is the fleet registration, which is optional. So it's like if you want this cluster to be present on multiple clusters, like the fleet, you logically group and normalize Kubernetes clusters, helping you up level management from individual cluster to group of clusters. So if you want to manage cluster, you don't need to go to individual cluster. If you add this cluster into a fleet, like suppose you are having 100 clusters, you can add those 100 into a fleet so that you don't need to go to each clusters to manage them. You can manage them from the single point of view. But this is optional. Let's go to networking. In networking, I'm using default networks for now. Public cluster, I'm creating a public cluster. There is an option to create private cluster also, but external users won't be able to access your private clusters. But for me, I want to access it through internet, so that's why I'm choosing public clusters. And then let's go to advanced settings. Target release channel, regular, balance feature availability and release stability. Automatically it will upgrade your cluster and all. You don't need to worry because we are in the autopilot. Then review and create. Let's follow this slide then. Go create in the cluster basic section, complete the following, enter the name of your cluster, which we already did, select a region, we have selected US Central one. In the networking section, choose public cluster, which is already there, and then finally create. So we are good to create this cluster, create cluster. Now, cluster creation takes times, it can take more than 5 to 10 minutes also. So I will pause this video and I will resume once this cluster is created. Okay, so it took some time for the cluster to come up and now our cluster is ready. So we can see the status is reporting green, so which is good. Now let's see. Now visit the cluster page in the console. Okay, first of all, we have created the cluster. Now once cluster is created, we need to add our container on this cluster. So before doing that, what I will do is, we have created this cluster. These are all the details which has been created, and that's why it took some time. Now to connect to this cluster using kubectl, what you need to do is you have to navigate to this cluster page, which I did, and you have to click here, connect. You will get some command line access. Just code copy it and paste it here. Kube config entry generated for demo GKE cluster. So this demo GKE cluster is the name of our cluster which we built as a autopilot configuration. Now the next part is, as we already create a autopilot cluster, let's run a workload as a Docker container. Now creating cluster is not enough, right? As per our diagram, we have now just created this cluster, and now I will show you where you will get the details of the node. So in the cluster, okay, I think we can check this in CLI also, so not to waste time. What we'll do is we'll directly go to the workloads, and here workload you will see nothing is created because we have just created the cluster only. Okay, now to create a workload, you need to create a deployment, and our deployment name, let's give Apache custom web. Okay, as we have created some custom image in Docker. Namespace I will keep default, those are advanced settings, and everything keeping on default. Let's go to the next step, which is, and which cluster it will use. So Kubernetes cluster is demo GK cluster. We have only one cluster we have created. So next, container details, and here image path. So enter your image path or choose from Google Container Registry. You can also enter the name of any public image from Docker Hub. Okay, so they give us the feature to use the public image from Docker Hub, and now you know that we have already added our image, which is demo image, to the Docker Hub. So let's copy the name of this image and put it here. Okay, so we are using our custom image which we have created at the start of this demo. Let's click done here. So this image is now added. Expose. So we have to expose it, right? Otherwise external users won't be able to access it. So I'm exposing it to port 80 because my container is also listening on port 80, as we have seen. So let's deploy. Now deployment is also, it will also take some time. So I will pause this video. Once deployment is done, we'll verify it. Okay, so now our workload is successfully deployed on this cluster. So in workload section, now it says the name of workload is Apache custom wedge, which we have given. Status is okay, and it is type is a deployment, as we have choose deployment as a type, and then the cluster is demo GKE cluster. Now to verify these things, let's go to our CLI. Now we will use kubectl get nodes, which I have said, like we can check in GUI as well, but GUI better to check in CLI, it is quick. Yeah, so you can see these two nodes have been created by GCP itself. So we have nowhere created this node with the name of our cluster, demo GKE cluster. They have created these two nodes for us. Now in this node, let's check what are the pods are created. kubectl get pods. So you can see three custom Apache custom wedge. This is the image which we have built using Docker, and we have uploaded to Docker Hub, and from Docker Hub we have imported it to our GKE workload configuration. And now the beauty of choosing deployment is automatically it has created 3 deployment for it, right? So 3 separate instance of my web is now active. Now to access this container over internet, what we need to do is we need to check for, first of all we'll check for deployments, like what are the deployments which have been created. Okay, it's capital deployments. Okay, so this is the Apache custom based deployment which we have created, in which 3 by 3 is a by default, up to date 3, available 3. Okay, so if any one of goes down automatically and you will be created, so desired state of 3 will be always maintained. And now let's do a command kubectl get service. Okay, So by default, you can see Apache custom web service is created as a load balancer type, which is a by default type because we have not choose that. And the external IP is this. Okay. And port listening is 80 because we have in the expose, we have set this port as 80. Okay. And we have left this by default setting of load balancer. So what I can do is I can open a incognito mode. And from here, I will try HTTP. HTTP will by default listen to port 80 and we'll see what happens. It says not secure. Okay, continue to the site. Network Kings, hello from container web server. So we can see using, first of all, what we did is from start, we have pulled the image, Ubuntu Apache 2 image from the Docker Hub. Using that image, we have created a container. We modified that container configuration with this default or custom, with this custom index.html code, so that every time this container runs, it should provide this web page, hello from container web server, networkings. And now what we did is we exported that image from our local system to Docker Hub. And then we created a autopilot GKE cluster. Inside that autopilot GKE cluster, we have created a deployment. In that deployment, we pulled this image which was on Docker Hub. So basically, this image which was in Docker Hub. So portability, which we have discussed, like the feature of using containers. So you have seen, as a developer, I have created one image in my local machine. And after that, that image I push to Docker Hub or any registry. There will be artifact registry used by Google or any registry, public registry should be there so that anybody can fetch the images, or private registry also if you have access to. So we can use those registries to upload your image, and from those registries you can download your image anytime you want them, right? So this is all related to containers. So let me go back to the slide. Now visit the cluster page in the cluster and click the autopilot cluster we created. At top, you will see a connector. We already did this and we verified all these commands. And if we focus on this diagram, so we have now checked that to connect to the cluster, GK cluster, we have used the connect CLI command. Once we type that command, we are into that cluster. Then kubectl get node have given us the information that 2 nodes were created. And inside 2 nodes, if I modify my diagram, something like this has been created. So 3 pods has been created for me by default, because we have not, in this lab we have taken all default values. So that's why, but believe me, like we have almost all level of controls, where which pod will sit on which node, in which region I want this node. Everything is manageable within GKEs. But as we have tested only the basic lab for this, so that's why we have chosen default setting. Otherwise this lab may have become more lengthy. So for now, I think we are good. So basically, this is how we proceed with our trainings, and this was just a demo. If you are like most of the things which are already present in this slide, but due to the time constraints, I was not able to explain them in details. So if you want to learn more about this GKE or about more Google Security Masters program, it will be worth contacting these numbers from our networkings. You can contact info@networkings.com. You can visit our websites at www.networkings.com. Then these are the toll-free numbers and the mobile numbers on which you can reach. Thank you very much for watching this demo. And now to access the complete course or the complete Google's Cloud Security Masters program, you will have to enroll for all access pass or the live access pass, and special discount is going on if you use my coupon code, which is Rohit GCP, which is listed on the screen. Please get in touch with below numbers with this coupon code, and you will definitely get the discount on the courses. Thank you very much once again. Have a nice day. Bye.